vector P is 6 meters along the x-axis and the vector Q is 8 meters along the y-axis. So the vectors are orthogonal to each other. P is 6 units along x and Q is 8 units along the y. So they are orthogonal or perpendicular to each other. So if the vectors are perpendicular or orthogonal to each other, the magnitude of the sum of two vectors is directly calculated using the Pythagoras theorem. Because cos of 90 degrees is immediately 0, so I can say this is the magnitude of p square plus the magnitude of vector q square, which is equals to 6 square plus 8 square, which is 100 meter square, which is 10 meters. This is the magnitude of vectors p plus q. That means if I use the parallelogram method, this is the magnitude of p plus q, or vector p plus q is this one, and the angle which the p plus q make with the x-axis is theta. So this value is simply the q component and this one is the p component. So theta can be calculated as a tan inverse of the magnitude of vector q divided by the magnitude of vector p, which is the tan inverse of the magnitude of vector q is 8 meter and this one is 6 meter, which gives us the tan inverse of 4 over 3. So tan inverse of 4 over 3 is exactly 53 degrees. So vector p plus q is equal to 10 meter at an angle of 53 degrees from x-axis. That means the vector with this theta is 53 degrees and this length is 10 meter from the x-axis. So the answer is A. Two vectors A and B are given. Vector A is I plus 3k and vector B is 2j plus 3k. So don't be confused here that vector A can be written as I plus 0j plus 3k. So we don't have the y component, it is 0. And also here we don't have I component, so it is 0i plus 2j plus 3k. We can rearrange the vector like this. So then what is the magnitude of the cross product is A and B? So from this we can see that first we have to find the A cross B vectors. A cross B is equals to, just I can use the Coleman formulas or the determinant formulas I, J and K. Components of A are 1, 0 and 3, and the components of B are 0, 2 and 3. So then I collect all the like terms, so the vector A cross B, which is equals to some term is I plus the some term is J plus some term is K. So we can write like this. So I is always J cross K, that means 0 times 3, which is 0, and 3 times 2, which is 6. So I make it minus because K cross J is minus I. So to get J is equals to K cross I. That means 3 times 0, which is 0, and minus 1 times 3, which is 3. And to get the K terms, K is I cross J. That means 1 times 2, which is 2, and 0 times 0, which is 0. So then this is equals to minus 6, I minus 3, J plus 2. K is the A cross B. But what is the magnitude of this vector? So the magnitude of A cross B vector is equals to minus 6 square plus minus 3 square plus 2 square under radical. So this is equals to under radical of 36 plus 9 plus 4, which is equals to under radical of 49, that is 7. So the magnitude of A cross B is 7. So the answer is alternative C. So vector A and B are given. Then what is the angle? Theta, the smaller angle between vector A and B. To do this, just we can use the concepts of the scalar product, which says cos of theta is the scalar product is of A and B divided by the magnitude of vector A and the magnitude of vector B. So from this, just we can calculate that the scalar product is of vector A and B is equals to radical 3 times radical 3, which is equal to 3, plus 1 times minus 1, which is equals to minus 1, and this gives us directly 2. And the magnitude of vector A is under radical of radical 3 square plus 1 square, which is 3 plus 1 gives us 2. And the magnitude of vector B is also under radical 3 square plus of minus 1 square, the whole under radical, which gives us also 2. Then the angle between vector A and B is the scalar product is of the two vectors, cos of the angle between them, divided by 2 times 2, which is the magnitude of vector A and B. So we can cancel 2 by 2 and I get 1 over 2. So this means that cos theta is equals to 1 over 2 implies theta is equals to the cos inverse of 1 over 2 or cos inverse of 0.5, which is immediately equal to the cos inverse of half is 60 degree. So theta angle between the two vector is immediately 60 degree. So the answer is on alternative A. Okay, which of the following pair of vectors are orthogonal to each other? We have given for vector A, B, C, and D. Then which of the pairs of the vectors on the given alternative is orthogonal to each other? So we have to check each one by one by using the orthogonality test. That means if two vectors are orthogonal, their dot product is, for example, let's say if vector A and vector B are orthogonal to each other, this implies that the dot product is of A and B are immediately 0. So this is how to test whether the two vectors are orthogonal or not. So let's test for A and D. If we take vector A is 4, 10 dotted with vector D is 15, minus 6. So this means 4 times 15, which is equals to 60, plus 10 times minus 6, sorry, this is minus 6, vector D is 15 minus 6. So 10 times 6 is, which is minus 60. So this is immediately 0. This means vector A and D are orthogonal to each other. So we can test for B and C. If we test for vector B and C, vector B is 2, minus 5. If we dot with vector C, which is minus 6, 15, this is equals to 2 times minus 6 is minus 12, minus 5 times 15, which is minus 75. So this is not orthogonal, this is negative of 85. So this is different from 0. So B and C cannot be orthogonal with each other. And still we can test for C and D on alternative C. So C dot D is vector C is minus 6, 15, and vector D is 15, minus 6. So this is minus 90, and 15 times minus 6 is also minus 90. this is minus 180, different from 0. So this cannot be orthogonal with each other. Then we can test for A and B. A dot B is equals to vector A is 4, 10 and vector B is 2, minus 5. So this is equals to 4 times 2 is 8 and 10 times minus 5 is minus 50. So this is negative 42. It's also different from 0, cannot be the orthogonal vectors. So according to the given alternative, the only vectors which fulfill the orthogonality test is on alternative A, the vector A and D. So the answer is on alternative A. Two forces F1 and F2 are given. So then what is the magnitude and the direction of the net forces? F net is equals to, this is force 1 plus force 2, the resultant force is, so this is equals to 8i plus 4i, which gives us 12i, and 3j plus 6j, which gives us plus 9j. So this is the net forces. So magnitude of the net force is equals to 12 square plus 9 square. So this is equals to under radical of 255, that is 15 Newton. And the direction of the vectors net force is equals to, it is tan inverse of 9 over 12, which is equals to the tan inverse of 3 over 4. This is gives us immediately 37 degrees. So then F net is in terms of magnitude and the direction, which is 15 Newton, 37 degree above the positive x-axis. So we can draw, if this is x and this is y, then the net force is 15 Newton at an angle from the positive x-axis. So the answer is D. Okay, the given vectors are represented the paths taken by the birds or when it's fly. So the birds flies like this. This is the first displacement, the second, the third, and the fourth one. Then the questions asks what is the resultant displacement followed by the birds. So the vectors are given in a diagram, that means in arrow representation of a vectors. So then if the vectors are drawn head to tail, then the resultant vector is the vector drawing from the tail of first vector up to the head of the last vector. So this is the tail of first vector and this is the head of the last vector. So if we connect these 2 points together, exactly we get the vector like this. So the red vector is the resultant displacement of the birds. So among the given alternative, which one shows the resultant displacement is? So exactly we can see from the diagram that alternative D represents the resultant displacement that is traveled by the birds. Okay, 3 Newton forces acting along the positive x-axis and 4 Newton forces acting along the positive y-axis. And then what is magnitude and direction of the force which balances these two forces? Is how much in magnitude and direction. So the force which balances the two means that if I add all the forces together, force 1 plus force 2 plus force 3 must give 0. That means F3 balances these two forces. So then the sum of all these three forces gives me 0, means the forces are in equilibrium, so they balance each other. So then from the equation, just we can get F3 is equals to minus F1 minus F2, which is equals to minus 3 I Newton minus 4 J Newton. So this is the third forces which balances the two. Then the magnitude of the third force F3 is equal to under radical of minus 3 Newton the whole square plus minus 4 Newton the whole square under radical, which gives me 25 under radical of 25 Newton square, which gives me the 5 Newton. Then the direction of these forces, then I can find the direction from the negative x-axis, and I can find directly this angle. So this unit is downward minus 4 and this is negative 3. So it is in the third quadrant. Both x and y components are negative. So these angles must be its tan inverse of minus 4 over minus 3, which is the tan inverse of 4 over 3 is 53 degree. So this angle is 53 degree, but the equation requires that the angle of these forces either from F2 or from F1. So this is F2 and this one is F1. So from F1 I have to add the 90 degree here. That means force F3 is equals to 5 Newton at an angle of 53 plus 90 degree. So F3 is 5 Newton at an angle of 53 plus 90 degree counterclockwise from F2. That means F3 is 5 Newton at an angle of 143 counterclockwise from F2. So this fulfills the required condition. So the answer is on the alternative C. Okay, to get the magnitude of the resultant velocities v1 and v2, so we have many options to do this question. So first let me show you these questions on a diagram. Velocity 1 is 10 meters per second northeast. That means at exactly 45 degrees from the east or from the north. And then the bird flies in 8 meters per second in the direction of south. So this is the first velocity and this one is the second velocity, and this must be the resultant velocity v. So then the first method we can do this is we resolve v1. That means v1 into its two component vectors. That means v1 x I and v plus v1 y j. So since this is 45 degree, the component along E and along the north, that means along the east and along the north, are equal. So I get the sine of 45, which is equals to cos of 45, that is 0.707, or its radical 2 over 2. Then if I multiply this, the x component or the component is along the east is 10 meters per second cos of 45, so 0.707 times 10 is 7.07 meters per second I, and also I get 7.07 meters per second is j. So this is the components of the first velocity, and the second velocity in component form is only along the south. That means I take it as a negative y-axis. That means minus 8 meters per second is j. So then the total velocity v is the vector sum of v1 and v2, which gives me 7.07 meters per second I plus 7.07 meter per second j minus 8 meter per second j. So this exactly gives me 7.07 meter per second I minus, so 7.07 minus 8 means I get exactly 0.93 meter per second is j. So then the magnitude of the resultant velocity is under radical of 7.07 meter per second the whole square plus minus 0.93 meter per second the whole square under radical. So this is equals to under radical 50.93 meter square per second square. So exactly gives me 7.13 meter per second. So the answer is on alternative D. So the second method I can do this question is just I draw the vectors from tail to tails, that means velocity vectors drawing tail to tail to get the angle between them. So the angle between them is exactly, this one is 45 degree and this is 90 degree. So the angle between two velocity theta can be 45 degree plus 90 degree, which gives me 135 degree. So this angle, the angle between two velocities when they are drawing tail to tail is 135 degree. Then I can apply exactly the cosine rule to get what I have calculated previously. So then the magnitude of the resultant vector velocity is equals to the magnitude of velocity 1 plus the magnitude of velocity 2 plus twice of the magnitude of v1 times magnitude of v2 and the cos of angle between velocity v1 and v2 by applying exactly the cosine law. Or just I can get the parallelogram by drawing these two vectors. So this is the resultant velocity v, or the sum of v1 and v2. So then the magnitude of v1 is 10 meter per second square plus the magnitude of v2 is 8 meter per second square plus twice of 10 meter per second times 8 meter per second cos of 135 degree the whole under radical. So these numbers gives me, this is 100 and this one is 64, that means 164 meter square second square plus, so we know that cos of 135 is equals to negative 0.707, or it is the negative of radical 2 over 2. Then if I multiply this number together I get 160 times minus 0.707. So this is meter square second square, don't forget it, the whole under radical. So this whole number gives me 164 meter square per second square minus 113.12 meter square per second square under radical, which is approximately equal to under radical of 50.87 meter square per second square. So exactly I get square root of this number is, then the magnitude of the resultant velocity is 7.13 meter per second. I get exactly the same answer as the previous one. Three vectors A, B, and C such that C is equals to the cross product is of A and B. So which one of the following is not true among the given alternative? If theta is different from 90 degree. Theta is the smaller angle between A and B when they are drawing tail to tail with each other. So then, concerning these given situations, which of the following alternative is not always true? So from alternative A, just we can say that from alternative A, if vector C is equals to A cross B, then B cross vector A is minus of C. This is always true because vector product is not commutative. That means that A cross B is the negative of B cross A. So if this one is C, this one is the negative of C. So alternative A is always true. So from alternative B, A dot C is equals to 0. So we can check also this. If C is the cross product is of vector A and vector B, then we can easily see that C is perpendicular to both A and to B. So that means the angle between C and A is 90 degree, and the angle between C and B is also 90 degree. If C and A are orthogonal and C and B are also orthogonal, the scalar product of C and A are 0 and the scalar products of C and B are 0, since the angle between A and C and B are 90 degrees. So they are orthogonal means, so we can say C dot A is 0 and also C dot B is also 0, or B dot C is also 0 and A dot C is also 0, since the dot product is commutative. Exactly, we see that alternative B is always true and alternative D is also true from these two conditions. So when we come to alternative C, which says A dot B is equal to 0, but the angle between A and B, theta, is different from 90 degree, just we have said. So A and B cannot be orthogonal or perpendicular to each other. So this is not true. It cannot be 0. If theta is different from 90 degree, the scalar product is of A and B cannot be 0. So the only not true answer, this is not true answer, is alternative C. Okay, the horizontal component of net force according to the diagram given is, just we can resolve these two forces. Let's say this is F1 and this is F2. F1 is 20 Newton at an angle of 37 degrees from the horizontal, and F2 is 50 Newton at an angle of 53 from the horizontal. So if I resolve the first forces, F1, which is 20 Newton at an angle of 37 degrees, so then F1 x is equal to 20 Newton times cos of 37. Cos of 37 is 0.8. So this is 20 Newton times 0.8, which exactly gives 16 Newton. So just I can write this is along the positive x-axis, so it is along this direction. F1 x is along this direction, so I can say 16 I Newton. So the second force is 50 Newton at an angle of 53 degrees from the horizontal. So it is the horizontal component of force 2, which is along x, is just F2x vector is equals to 50 Newton cos of 53 degrees. But cos of 53 degrees is exactly equal to 0.6. So this is equals to 50 Newton times 0.6, which exactly equal to 5 times 6 is 30 Newton. So since it is on the left, that means along the direction of negative x-axis, F2x is equal to negative of 13 Newton I. So the net horizontal component is the horizontal components of the net force is the sum of the horizontal components of force 1, which is 16 Newton I plus minus 30 Newton I, which gives me minus 14 Newton I. So just I can write I in terms of north, south and west. I can use the geographical direction. This is north, this is south, this is east and this is west. So north can be considered as positive j, and east is considered as positive I, and south is considered as negative j, and west can be considered as negative I. So this means minus 14 Newton I means the net force is 14 Newton along the west. So the answer is on the alternative C. A position vector of an object A, describe its distance from a given point in all direction. B, describe its distance from a point in a specified direction. C, a measure of how fast it is moving relative to stationary reference frame. D, is independent of the origin from which it is measured. So from this given alternative, we can see that the correct answer which describes the position vector of an object is on alternative B, which says it describes its distance from a point in a specified direction. So the correct answer is on alternative B. So two forces F1 and F2 are given. F1 is 10 Newton at an angle of 30 degrees above the horizontal, and F2 is 20 Newton at an angle of 60 degrees above the horizontal. This is force 1 and this is force 2 when they are drawn on the same coordinates. So just according to the given alternatives, I have to find the components of F1. F1 can be written as F1x I plus F1 y along the j. So this is equals to F1x means the magnitude of F1 times the cos of an angle or 30 degree, which is 10 Newton cos of 30 degree I plus 10 Newton times sine of 30 degree j. So this is equals to immediately cos of 30 degrees 0.866 and sine of 30 degrees is half. So this is 8.66 Newton I plus this one is 5 Newton j. So this is the component of force 1, and the components of force 2 are F2 along x I and F2 along yj. So this is equals to 20 Newton cos of 60 degree I plus 20 Newton sine of 60 degree j. So this become cos of 60 degrees half and sine of 60 degrees 0.866. So exactly we can get this is 10 Newton I plus 17.32 Newton j. So this is the component of the second force. So then the resultant force F can be the sum of F1 plus F2, which gives me that 8.66 plus 10 is 18.66 Newton I, and 5 plus 17 is 22.32 Newton j. So this is the components of the resultant vector, and the magnitude of the resultant force is under radical of 18.66 Newton square plus 22.32 Newton square under radical, which gives me directly under radical of 846.378. This is exactly equal to 29.09 Newton. So this is the magnitude of the resultant force, and the direction of the resultant force is the tan inverse of its component is, so 22.32 divided by 18.66. so this gives me that 50.1 degree above the horizontal. So among the given alternative which fulfills the condition is on alternative B, which says the horizontal and vertical component of the resultant are 18.66 Newton and 22.32 Newton. So this is the components of the resultant vector. So the answer is exactly on alternative B. So four vectors are given, A, B, C, and D. Then which pairs of the vectors are collinear? So to do this, we use exactly the colinearity test of a vector, which states if vector A and vector B are collinear, collinear means either they are parallel or opposite. That means the angle between the two vectors is either 0 degree or 180 degree. So then the vectors are said to be collinear. That means the cross products of the two given vectors are immediately 0. So this is what we call the colinearity test of the vector. So on alternative A, we check for A and B. That means whether A and B are collinear. So I have to do the vector products of A and B. So to get the I terms, I cross J and K. That means that is minus 1 times 0 is 0, minus 2 times 0 is also 0. So I don't have the I terms. To get the J, I cross K with I. 0 times 4 is 0, 2 times 0 is also 0. I don't have the J terms. But easily we can see that if the Z components of the vectors are 0, both vectors are 0, so the I and the J components do not survive in the cross product. The only term which survive is the K1, so which is I cross J. 2 times minus 2 is minus 4, minus of 4 times minus 1 is minus 4. This is minus 4, so this is equals to 0i plus 0j plus minus 4 plus 4, which is also gives us 0. So since the cross product is of A and B are 0 on alternative A, then the vectors A and B are collinear with each other. So if we are on exam, just you can leave here, but let's check further for the other possibility. Okay, on alternative C, we have to test for B and C, the pair of vector B and C. So B and C, the component of B is 4, minus 2 and 0. The component of C is 1, minus 1 and 0. Then if I do the cross product of them, the I and the J terms are goes to 0 because K terms is 0 here, but the term which survive is the K1. That means K is minus 2K. So since this is different from 0, vector B and vector C are not collinear. So on alternative C, for vector A and C, just as before, since the K components of the both vectors are 0, then I and J terms become 0, but only K terms survive. This is minus 1K or simply negative K. So then it's different from 0. A and C are not collinear. So on alternative D, if we test for C and D, so here also since the Z components of the both vectors are 0, so then I and J terms of the cross product do not survive. Here only we have the K terms, that is 1 times 3 is 3, minus of is 2 times minus 1 is minus 2, which gives me 5k. That is the 5k. It's different from 0. So vector C and vector D are also not collinear. So the correct answer, which gives me the pair of collinear vector, is vector A and vector B, which is on alternative A. Okay, we can do the collinearity tests without doing the cross products by using the method of inspection. So this method is so simple. Without doing any calculation, we can identify whether the given pairs of vectors are collinear or not. So for example, we can see here that we have the 4 quadrats here. If this is x and y axis, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If we check all the vectors, vector A is exists in quadrant 4, B is in quadrant 4, C is also in quadrant 4, and D is in quadrant 1, or in the first quadrant. For the vectors to be collinear, they must exist either in the same quadrant or the quadrant which is opposite to the other. That means that if one vector is existing in quadrant 1, the second one is also must be existing in quadrant 1 or in quadrant 3. So this is the condition that we check for the collinearity of a vector by an inspection. And if vector is exists, one vector exists in quadrant 2, the second one is must be exist in quadrant 2 or in quadrant 4 to be a collinear with the first one. So this is the method of an inspection. So without doing any calculation, if the vectors are exist in the same quadrant or the quadrant which is opposite to each other, then directly we can test for their collinearity without doing their cross products by dividing their components to the other component, or by taking the ratio of their components. Then if the vectors are exist in the same quadrant or in opposite quadrant and their components, the ratio of their components are equal, then the vectors are said to be collinear with each other. So for example, on alternative A, just we can test for vector A and vector B whether they are collinear or not by using the method of inspection. So just we can say first of all that vector A and vector B are both exists in quadrant 4. That means both A and B are in quadrant 4. That means there is a chance of A and B to be collinear with each other. So then, since the ratio of the components of A, 2 divided by minus 1, which gives me minus 2. So I get minus 2, and if the ratio of component of vector B is also equal to minus 2, then since they are exist in the same quadrant and the ratio of their components are equal, then they are said to be collinear with each other. So let me check for the components ratio of the components of vector B, that is 4 divided by minus 2. So I get immediately negative 2. That means since the ratio of components of vector A and B are equal, by inspection A and B are collinear with each other. From alternative B, B and C, if we check for vector B and C, both vector B and C are exist in quadrant 4, so there is a chance of being collinear with each other. But let's check the ratio of their components. If I divide the ratio of component of B with each other, I get minus 2, and then if I divide the components of C with each other, 1 divided by minus 1 is, I get directly 1 divided by minus 1 is minus 1. So minus 1 and minus 2 are not equal, so C and B are not collinear with each other. On alternative C, A and C are also both exist in quadrant 4, so there is a chance of being collinear with each other, but the ratio of components of vector A is negative 2 and that of C is negative 1. So even though they exist in the same quadrant, the ratio of their components are not equal, so the vectors are not collinear with each other. But when we come to alternative D, which says vector C and D, for vector C and D, we are not going to divide the ratio of their components because vector C exists in quadrant 4 and vector D exists in the first quadrant. So by any means, these two vectors cannot be collinear with each other. Force of 10 Newton is acting in the direction of northeast. So this force is acting on the direction of northeast. Then which of the following graph represents the graphical representation of this force? So if I draw these forces like this is north, this is south, this is eastern, this is west. Northeast means exactly in the first quadrant. The diagram which represents this vector is exactly on C. So the answer is on C. Two vectors are given, vector A 8 unit east and vector B 6 unit north. So which diagram represents the graphical representation of the sum of the two vectors? So if I draw these two vectors, vector A is along the east, that is 8 unit along the east, and vector B is along the north. So their directions look like this. This is vector A and this is vector B, which is along the north. So if I add graphically, I draw head to tail or tail to tail. So if the vectors are drawing head to tail, the resultant of the vectors must be this is vector A, which is 8 unit, and this is vector B, which is 6 unit, and the resultant is drawing from the tail of first vector to the head of the last one. That means from the tail of vector A up to the head of vector B. So the correct diagram is exactly on alternative C. So which pair of vectors are collinear with each other? So we use the we find the pairs of the vectors which are collinear to each other, either parallel or opposite. So without checking each one by one by using the collinearity test, so by inspection I can identify exactly without doing any calculation by using the method of inspection. So here on A, this vector is in first quadrant and this vector is in the fourth quadrant. The vectors in the first and fourth quadrant cannot be collinear with each other. So there is no possibility for these two vectors to be collinear with each other. When you come to B, the first vector is exists in quadrant 3 or the third quadrant, and this one is in the fourth quadrant. So fourth and third quadrant has no possibility to be collinear to each other. So third and fourth quadrant vectors cannot be collinear with each other. When we come to C, first vector is exists in the first quadrant and this vector exists in the third quadrant. So the first and third quadrant vector has a possibility to be collinear with each other. Then I take the ratio of the components of the vector C, which is 4 divided by 2 gives me 2, and minus 4 divided by minus 2 is also 2. So the ratio of the components are equal and the vectors are exist in the quadrant which is opposite to each other. So on C, vector are collinear with each other. So when we come to vector D, vectors on alternative D, the first vector is exists on the first quadrant and the second vector exists on the second quadrant. So first and second quadrant has no possibility to be collinear with each other. So there is no possibility here. So the only alternative that we have or which fulfill the condition of collinear is on alternative C. So you can test also for the vectors on alternative C by using the collinearity test, that is by cross product, taking cross products of these two vectors. So you can take I, j and k, and the cross products become 0. This is 4 to 0. This is -4, -2, and 0. Here, since the k terms is 0, I and j do not survive, only k terms are survive. That means k is I cross j. 4 times -2 is -8, -4 times 2 is -8. So this is equals to -8 plus 8, which exactly gives us 0. That means the vectors on alternative C are collinear with each other. So the unit vectors along the direction of vector A is unit vector A is equals to vector A divided by magnitude of vector A. So the magnitude of vector A can be calculated as magnitude of vector A is, which is 3 square plus 4 square, that is 25, and gives us 5. So then the unit vector A is 3i plus 4j divided by 5, 1 over 5 into 3i plus 4j, or I can say 3 over 5i plus 4 over 5j. So this is the unit vectors along the direction of A. So the answer is on alternative C. Okay, this question also about the collinear pairs of vectors. So on alternative A, we have two vectors, 2i plus 3j and -4i plus 6j. This vector is in the first quadrant and this vector is in the second quadrant. So first and second quadrant has no possibility to be collinear with each other. When you come to alternative B, 2i plus 3j and -4i minus 6j. So these two vectors has a possibility to be collinear with each other because the first vector is in quadrant 1 and this one is in quadrant 3. That means the first one is in this direction and the second one is in this direction. So there is a possibility for them to be collinear with each other. So then, if there is a possibility, by using the method of inspection, I divide this value, that means 2 over 3, and also I test for the components of the second vector, which is -4 over -6, which is directly 2 over 3. So the ratio of their components are equal and the vectors are exist in the opposite quadrats. So these vectors are collinear with each other. Alternative B, vectors are collinear with each other. When we come to the vectors on alternative C, the first vector exists in quadrant 2 and this one is in quadrant 3. So the vector is in quadrant 2 and the vectors in quadrant 3 has no possibility to be collinear with each other. And also on alternative D, first vector is exist in quadrant 1 and this one exists in quadrant 2. So the vector in quadrant 1 and quadrant 2 has no possibility to be collinear with each other. So the only pair of vectors which is collinear with each other is the vectors on alternative B. Two vectors v1 10 unit along the positive y-axis and v2 6 unit at an angle of 37 above the positive x-axis. So if we draw v1 is along the positive y-axis 10 unit and v2 is 37 degree 6 unit above the positive x-axis. So exactly we can see that the angle between the vectors theta is 53 degree That means the angle between vector v1 and v2 is 90 degree minus 37 degree, which is exactly 53 degree. Then the scalar product is of v1 and v2, that is v1 dot with v2 is equals to magnitude of v1 times magnitude of vector v2 and cos of the angle between them. So magnitude of v1 is 10 unit times magnitude of v2 is 6 unit times cos of 53 degree, which is the angle between A and B. Cos of 53 is 0.6, exactly we have 36 square of units. So the answer is B. The torque produced by the force is equal to always the cross products of force and or the position vector from the axis of rotation. So that is, I can use directly the determinant form. So R has only one component, which is along X, the rest are 0, and the force has two components, X and the K component is, which is 1, Y component is 0, and the K component is -3. So directly we can see that I is equals to J cross K. Then we can collect this torque is equals to the component is along I plus the component is along J plus the component is along K. 0 times -3 is 0, 0 times 0 is also 0, this is 0 minus 0, we don't have I terms. J term is J is equals to K cross I, 0 times 1 is 0 and minus of 4 times -3 is -12, and when we come to K, K is equals to I cross J, so 4 times 0 is 0, 0 times 1 is also 0, so this is 0 minus 0. So as we have expected, the I and K term is 0 and only J terms are survived. So 0 minus -12 is +12 J Newton meter. So the correct answer is on alternative C.